Last time we discussed functional notation. We said that if we have a function, such as y is equal to x squared minus 2x, we can replace the y with the notation f of x. And this is how we usually label functions. We'll put a letter here. It doesn't have to be f, it could be g, could be h, could be any letter you want, and then you put parentheses x parentheses. So that's how we'll see and write functions in this course. So let's say we have this function x squared minus 2x. Let's find the following. F of 2. Well, recall this means that we just plug in 2 wherever we see an x. So this is 2 squared minus 2 times 2, which is 4 minus 4, which is 0. How about f of x minus 1? Well, we plug in x minus 1 wherever we see an x. So this is x minus 1 squared minus 2 times x minus 1. And now we need to simplify this. This piece right here we need to FOIL. Remember that x minus 1 squared is the same thing as x minus 1 times x minus 1. And then let's distribute this negative 2 to everything inside this parentheses. And now let's FOIL this. This is x squared, a minus x, and then another minus x, plus 1 minus 2x plus 2. So simplify this, we get 1, 2, 4. So negative 4x plus 3. So I have a negative 1, a negative 1, and a negative 2. So that makes a negative 4. And then a 1 and a 2 make a 3. Okay, let's figure out what f of x plus h is. Again, in the original function, x squared minus 2x, we plug in x plus h for every x. We're going to have to FOIL this out. So this is x plus h times x plus h minus 2x minus 2h. This is x squared plus x times h, and then an h times x, which makes 2xh, plus h squared minus 2x minus 2h. Be very careful here. Don't fall into the trap of squaring everything on the inside. You see, I do have the x squared and the h squared, but I also get a 2xh when I FOIL this. So it's not x squared plus h squared, it's x squared plus 2xh plus h squared. Same thing here. This is not x squared plus 1, this is x squared minus 2x plus 1. So always remember that when you have a square like this with these parentheses, write it twice and then FOIL it out. Okay, we can't simplify this any further. You see that we either have different variables or different powers on our variables, so this is as simplified as we can get. So f of x plus h is x squared plus 2xh plus h squared minus 2x minus 2h. Here's another one. This is actually famous. It's called the difference quotient, and you use it a lot in calculus. What we're going to do is we're going to figure out what the difference quotient is. We're going to put in f of x plus h, which we've already found. We're going to subtract the original function, f of x, and then divide by h. So this is equal to f of x plus h. Well, remember our function, I'm going to write it here. It was x squared minus 2x. And we've already found f of x plus h. It's right here. So what I'm going to do is I'm going to substitute this in. So I get x squared plus 2xh plus h squared minus 2x minus 2h. All of this is this piece. Then we subtract the original function, which was x squared minus 2x. Be very careful here. You're subtracting the whole thing. I see a lot of students will just do this. They won't put parentheses around this. And what happens is this negative is only subtracting the x squared. you're not subtracting the 2x. Make sure you put parentheses around the whole thing because you need to distribute this negative to everything in the inside here. Then we take this and we divide by h. So this piece is here, this piece is here, and then we divide by h. I'm going to clean this up. I'm going to distribute this negative, so I get x squared plus 2xh plus h squared minus 2x minus 2h minus x squared plus 2x. You see how I distributed that negative and this became a positive 2x, all divided by h. And the amazing thing about this difference quotient is you always get something to cancel out on the top. You see how this negative x squared, it got rid of this x squared term because I have a positive and then a negative, and then this negative 2x cancels out this 2x. So anything that didn't have an h in it, this piece, goes away. So I'm left with 2xh plus h squared minus 2h divided by h. And this h is going into every single thing here. So this is the same thing as 2xh over h plus h squared divided by h minus 2h over h. You can see that these h's cancel. And then you can get rid of one of these h's. And you're left with 2x plus h minus 2. So 2x plus h minus 2. Let's do another one of these just to make sure that we understand it. So I'm going to give you another function. I'm going to give you an easy function. You might see something more complicated on your homework, but I want to make sure that we can actually follow the difference quotient. So let's say f of x is the function 3x minus 2. And I want to find the difference quotient f of x plus h minus f of x divided by h. All right, let's work through this. First thing we need to find is this piece. So f of x plus h means that in my original function, I plug in x plus h wherever I see an x. Distribute this, we get 3x plus 3h minus 2. Now we're going to take this and plug it into here. And then we subtract the original function and divide by h. So you can see that f of x plus h minus f of x divided by h is 3x plus 3h minus 2. That's this first piece. Subtract the original function, 3x minus 2, all divided by h. Distribute this negative, and you'll see you'll get a negative 3x, which cancels out this positive 3x, so those will go away. And then you'll get a plus 2, which will cancel out this negative 2, and you're going to be left with 3h over h. Again, like I said, anything without an h over here gets canceled out, just like the last problem. You see how here we had an x squared and negative 2x. Those were the only things without h's. They get canceled out. So we have 3h over h. The h's go away, and we're just left with 3. So that is equal to the difference quotient. All right, let's move on. Oops, sorry about that. The screen, I'm gonna have to scroll back down. Okay, here we were. It's annoying. One more time. Okay, so now let's talk about the domain of a function. We've talked about it before. We said that the domain of a function is all the values you're plugging into the function. I'm going to give you a definition that you're going to use to help you figure out when you're given a function, the equation of a function, how to determine what its domain is. So the domain of a function f is the largest set of real numbers for which f of x is a real number. So you're trying to find the set of real numbers that you can plug into your function. Let's find the domain of the following functions. So to me, for example, this problem here, h of x is 3 over x. It's easier for me to figure out what I can't plug into this, into x. So we're looking for everything that we cannot plug into x, and we're going to get rid of that, okay? So here I have 3 divided by x. What number can I not divide by? I cannot divide by the number 0. So x cannot be 0. That's the only number I cannot divide by. You can put whatever you want here. You can put a 1. You know what 3 divided by 1 is. You can put that in your calculator. It's just 3. You could put a half here. That'll be 3 divided by a half is 6. You could put negative 1,000. That's okay. You can put anything you want. The only thing you can't put in here is 0. So we're looking, when we say find the domain of this function, we're looking for all the numbers we can plug into here, okay? And the way you figure that out is figure out what you can't plug in, okay? So x can't be 0. So there's several ways to write this. You could say that the domain is all of the x's such that x is not equal to 0. This is called set notation. But a really common form of notation is called interval notation. So the interval notation for this is you put from the left to the right. You're going to put the smallest number x can be to the biggest number x can be. And if there's something you have to take out, you get rid of it in that interval notation. So for example, the smallest thing x can be is negative infinity. You can go out all the way out there to negative infinity, then comma, you're going to go up to as far as you can go, which is 0, but you can't be 0, so we put a parenthesis here, union 0 to infinity. Okay, so remember, from left to right, you put the smallest number you can be, negative infinity. You can put anything from negative infinity to 0, but you can't put 0, so you're making a jump. You say anything from 0 but not including 0 to infinity. So parentheses means that we cannot be that number, okay? And the reason we put parentheses here is because you can't, infinity is not a number, it's a concept. So you're putting parentheses here. If you can equal a number, you put brackets like this. But when you can't be a number, you just put a parentheses. So we're gonna do some more problems, especially if you're not familiar with interval notation, okay? So this is the first one. I think you'll catch on pretty quickly. Let's look at another problem. Here I have f of x is 1 minus 2x squared. So let me ask you, is there any real number that I cannot plug into x? Well, let's think about it. Can I put 0 into here? Well, I get 0 squared, which makes this 0, and 1 minus 0 is 1. Okay. Can I put a negative number in here? Any negative number I want to, like negative 3,000. Well, I just square it, multiply it by 2, and then make that a negative and add 1 to it, right? I'll get a number is what I'm saying. I can put any number I want to in for this x. I just square it, multiply it by 2, say 1 minus that number, and then I get a real number here. So there's nothing I cannot plug into here. So there's nothing I cannot plug in to x. Another way to think about it is, if you put a number into here and you try to put it in your calculator, would you get an error for any number you plug in? And the answer is no. You can plug in whatever you want. So because I can plug in anything, the domain of f is all real numbers. In interval notation, well, what you write is the smallest number x can be. So since it can be all real numbers, we can go out all the way to negative infinity, and then we can go all the way up to positive infinity. So you go from smallest to largest, and because I don't have to take anything out, this is my interval notation. So parentheses, negative infinity, comma, positive infinity. Here's the next problem. I want the square root of x for my function g of x. What is the domain of g? Again, we want to think of all the numbers x cannot be. Is there anything you can't take a square root of? Let's see, can we take the square root of 1? Yes, that's just 1, right? In fact, you can take the square root of any positive number. You can take the square root of 2. You put that in your calculator. It's going to be a little bit bigger than 1. You can take the square root of 3. You can take the square root of 100. You can take the square root of any positive number. Can you take the square root of 0? The answer is yes, because remember what a square root is. It tells you the number that when you square it, you get 0. So 0 squared is 0. Again, like 4, the square root of 4 is 2. That means 2 squared is 4. So when I'm taking the square root, that means I'm looking for the number that when I square it, I get 0. And 0 happens to be that number. Can I take a square root of a negative number? Like the square root of negative 1. You could put that in your calculator and you're going to get an error. Why are you going to get an error? Because you're looking for a number x that when you square it, you get a negative 1. There's no way to square a number and not get a positive number, okay, or 0. So x cannot be negative. So the domain of g is all x such that x is greater than or equal to 0. So you can put anything you want that's 0 or bigger into this function, and you're going to get a real number. You're going to be able to take the square root and get a number for it, just like that definition said. So we're looking for all the numbers, the largest set that we can plug in and get a real number. So this is the domain of g in set notation. Let's see if we can put it in interval notation. So again, how you do interval notation, you're going to have a number here and a number here. Maybe you might have more than just a set. You might have a union here. But for this particular problem, I'm going to put a number here, and either a bracket or parentheses on both sides. So I ask myself, what's the smallest number that can go into here? And that's 0. You see? You have to be greater than or equal to 0. If I can equal that number, I'm going to put a little bracket here. Okay? Then I ask myself, from 0, what's the biggest number I can be? There's no limit here. I can go all the way out to infinity. I can never equal infinity, so I put a parenthesis here. So this is the interval notation. So this is also the domain of g. So either one of these is correct. You can put this or this. Your homework will ask you either for set notation or for interval notation, and interval notation would be this. So we're going to do a lot of examples. Here's the next one. I have f of x is the square root of 2 plus x. This is very similar to the last problem. So what can you not put in for x? Remember that this whole thing, 2 plus x, it has to be greater than or equal to 0. So what does that tell you about x? Because that's what we're trying to figure out. The domain is the values of x. So if we move the 2 to the other side, we see that x is greater than or equal to negative 2. Let's see, plug in negative 2, you get 0, you can take the square root of it. something bigger than negative 2. Negative 1, if you plug in negative 1, you get 2 plus negative 1, which is 1. You can take the square root. But if you put negative 3 in here, you're going to get the square root of negative 1, which you can't take the square root of. So it has to be bigger or equal to negative 2. So the domain of f in interval notation is x such that x is greater than or equal to negative 2. Now let's write this in interval notation. The domain, now again, think about the smallest number you can be. That is negative 2 up to the biggest number you can be, which is infinity. This one's similar again, and it's all we have to do is whatever's under this square root, we set it greater than or equal to 0, so we get x is greater than or equal to 4. Okay, see how this is very similar to the last one? Maybe pause the video and try to write this in set notation and interval notation. So the domain of G is all the x such that x is greater than or equal to 4. Or you could say from 4 to infinity. How about this one? Well, is there any restrictions on what you can plug in for x? Is there anything I cannot plug in for x? The answer is no. You can plug in 0, because 0 times 2 is just 0. Plug in a negative, a positive. The domain here is all real numbers. And you can write that as negative infinity to infinity, the smallest you can be to the biggest. Right now, the only time you're not going to have the domain being all real numbers for this section is when you see square roots and fractions. I think that's all that you're going to see, that when you're going to have something you have to take out of the domain. Okay, so like this one. Here I have a fraction. What number can I not put in the denominator? X cannot be 7, right? Because if I put in 7, I'm dividing by 0. So that's a problem. That's the only number I can't plug in. Can I plug in negative 3 into here? Well, I'll get 0 on the top, but that's okay. 0 divided by any number is 0. The problem is when you divide a number by 0, you get an error. So this is undefined. Okay, so putting 0 in the numerator is okay. 0 in the denominator is not okay. So this is the only number you have to take out. So in set notation, the domain of J, notice that I'm using a different letter, but still, because of the way it's written, is a function. The domain of J is all the x such that x is not equal to 7. But you could also say the domain of J in interval notation is negative infinity to 7, union 7 to infinity. You go from the smallest number you can be, go up all the way to the biggest number you can be, which is 7 for right now, and then you have to jump because you have to take that 7 out. And then we go from 7 to infinity. Because we can't equal 7, we have to put parentheses here. Okay, next one. X plus 2 over x squared minus 25. Again, don't worry about the numerator. It's the denominator we have to pay attention to. So this x squared minus 25, this cannot equal 0. So what does that mean? Well, you can factor this if you know the difference of squares formula. You could also just move the 25 over to the other side. So this factors into x minus 5 times x plus 5 is not equal to 0, okay? In other words, x minus 5 is not equal to 0, and x plus 5 cannot be 0. If you plug in 5 or negative 5 into here, you're going to get 25, and 25 minus 25 is 0. We don't want that. So we can't equal either one of these numbers. But those are the only two numbers that we get a problem when we plug it into here. Okay, so how can we write the domain? So the domain of f, in set notation, is all the x such that x is not equal to plus or minus 5. But what I'm really concerned about is the interval notation. All right, let's see if we can do this. So we say the smallest number we can be. We can go all the way out to negative infinity. Then we work our way up. So we go from negative infinity all the way to, well, what's the smallest number that we have to take out? That's negative 5, right? We jump. And then we can be anything from negative 5 to 5, right? 0 is in between negative 5 and 5, and I can plug that in. Then we take another jump, and we go from 5 to infinity. So we have to write these 3 intervals. A lot of students will forget to put this interval, and that's bad because you're skipping all the numbers from negative 5 to 5. So you need to make sure you have that interval. Okay, here's another one. G of x is equal to the cubic root of x. This one's actually a little tricky. Turns out that the domain of G is all real numbers. So again, negative infinity to infinity. How do I know that? I'm going to teach you a little trick here. If this number here is odd, the domain is always all real numbers. If this number is even, then it's going to be whatever's under here has to be greater than or equal to 0. Why is that? Taking the cubic root of something means you're looking for, so let's say the cubic root of 8. You're looking for the number that when you cube it, you get 8. It turns out that 2 times 2 times 2 is the number you're looking for. But what if I put, instead of 8 here, I put negative 8, so a negative number? Is there a number that when you cube it, you get negative 8? And the answer is yes. It's the same number you found, but just the negative of it. Because a negative times a negative is positive, and then if we multiply it by a negative again, we get a negative. So you can put negative numbers in when this is an odd number. So if it was like a 5 here, or a 7, or a 9, you can put a negative in there. And it's the same principle here. If this was a 5, you're looking for something that when you raise it to the 5th, you get a negative number, and you can find something because multiplying something 5 times that's negative will be negative. So again, odd number here is all real numbers, the domain. If it's an even number here, like a 4 or a 6, you can't ever get a negative. So the domain is going to be whatever's under here is greater than or equal to 0. Okay, it looks like we're getting a little more complicated. Here I have a fraction, and I have something in the denominator. When we see a fraction, we want to say that whatever is in the denominator cannot be 0. So x cubed plus 3x squared plus 2x, this can't be 0. We need to figure out all the x's that when we plug them into this expression, we get 0. When we get 0, those x values, we have to take them out of the domain. So what you're going to do is you're going to factor, because that's how you're going to figure out what the x values are. So first thing I do is I look to see if they have a greatest common factor. Each one of these has an x, so we can factor that out. And now try to factor this. The way I factor this is I make an x here, and I say, okay, I need two numbers that multiply to give me 2 and add to give me 3. It doesn't matter which way you put these, but I think, so I put the 2 at the top and the 3 at the bottom. So I have a positive 2 that goes here, and then I have this 3, this positive 3 down here. So two numbers, multiply to give you 2, add to give you 3. Positive 2 and a positive 1 work. Multiply them 2, add them 3. So that tells you when the coefficient of this one is 1, you just say x plus this number times x plus this number. This piece here factors into these two pieces, and I had to bring the x down for the ride because he was on the outside. So you can cover this. You see that this is equal to this, but we had an x to begin with. Okay, we factored this. So what does this mean? This means that each one of these pieces can't be equal to 0, because if I plug in 0 here, the whole thing multiplies to 0. If I plug in a negative 2, this will be 0, and anything times 0 is 0. So what I'm getting at is x can't be 0, x plus 2 can't be 0, and x plus 1 can't be 0. So we see that x can't be 0, negative 2, or negative 1. So we have to take these three numbers out of the domain. I'm just going to write this in interval notation. So the domain of, I believe this was, I didn't even call it anything. Let's call it f of x. So the domain of f of x is equal to, in interval notation, I'm going to do it in green. Okay, we have three numbers. Let's put them from smallest to largest. So negative 2, negative 1, 0. Okay, so we start with the smallest number we can be, which is negative infinity. We go up until we reach a problem, which is negative 2. We jump, we go from negative 2, then we keep going up until we reach our next problem, which is negative 1. We jump, we go from negative 1 to our next problem, which is 0. Jump, 0 to next problem. Well, there's no more problems, so we can go all the way to infinity. So this is the interval notation. All right. Okay, so now look at this. This is getting even tougher. We have a square root and a fraction in one function. What is the domain of this function? Maybe you can pause the video and see if you can figure out what values you can't plug in. Okay, so we have a problem in the denominator. X cannot be 3, because if I plug in 3, I get 0, and that's a problem. I also have a square root, and we know with square roots, whatever under the square root has to be greater than or equal to 0. So x has to be greater than or equal to negative 5. So first, x has to be greater than or equal to negative 5, but it also can't be 3. We need the intersection of these two. So I'm bigger than negative 5, so anything bigger than negative 5, but take that 3 out. So how do I write this domain? What's the smallest number I can be? The smallest number is negative 5. I can't go below that, but I can equal negative 5, so I'm going to put a bracket here. Then I go up until I reach my first problem. Well, the only problem I have is this 3, so I have to take it out. Okay, but then I go from 3 to infinity. That's it, that's the domain. Set notation, you can say x such that x isn't 3 and x is greater than or equal to negative 5. That would be fine. So when we find these pieces, we're basically finding the set notation. I think maybe this is the last one. Let me just scroll down to make sure. Yep, that's the last one. Okay, maybe pause the video, see what you can do with this problem. See if you can figure out any issues and what you need to take out. Okay, this one's a little tricky. Remember that the top doesn't matter if there's no square root, so we don't have to worry about this. It's the denominator. That's what we need to pay attention to. So we have that because this is in the denominator, x times the square root of x plus 2 cannot be 0. First off, okay? So whatever is here, this x can't be 0, and this piece can't be 0. Okay, so x can't be 0, and the square root of x plus 2 can't be 0. But we also have a square root, and we have to worry about what we can plug in to that square root. So x plus 2 has to be greater than or equal to 0. So x is greater than or equal to negative 2. Okay. We need to pay attention to this piece as well. So normally what I would say is, if the square root was in the numerator, it would just be that x is not equal to 0 and x is greater than or equal to negative 2. Because the thing can't equal 0, what happens if you plug in negative 2? If you plug in negative 2 here, you get the square root of 0, which is 0. And then you have negative 2 times 0, which is going to be 0. So it turns out, because of this piece here, I actually have to get rid of the equal sign. So x has to be greater than negative 2, and x can't be 0. So what's the smallest number you can be? Well, you've got to go to negative 2. Anything above it will work, but not negative 2 and nothing below it. So parentheses on negative 2. Then we go to our next issue, which is 0. We take it out. Union 0 to infinity. All right, something you might have noticed is that there's a greatest common factor here. The greatest common factor is x. And something you might have thought was to say that I of x is x times x minus 4 over x square root x plus 2. And then you might have thought, oh, I can get rid of this x. And this is the same thing as x minus 4 divided by the square root of x plus 2. Well, not quite. Your original function had an x in the denominator. This is the simplified version. It's not actually equal to this. It's just, it is the same thing, but you're ignoring that you had an x in the denominator. You're simplifying it. So you can't just mark these x's out without saying we have to take it out of the denominator. Look, you had this x here to begin with. You can't plug in anything right here that's a 0, right? This is the original function. This is the simplified version. So again, it doesn't look like x is equal to 0 is a problem here, but this wasn't the original function. This was, okay? So x being 0 is a problem.